Explain transformation of independent variable. Here we are taking an example of an airplane landing. The pilot gives the command for opening of the main back wheel to the control system. The command of the pilot is transformed into a mechanical action via electrical and mechanical systems, thereby allowing the opening of the wheels. Finally, the back main wheels are dropped for landing. Here the pilot's command is the independent variable whose transformation leads to a change in the system, that is, opening of the wheels for landing. Thus, on correlating our example with the definition, we can say that transformation of independent variable refers to modification of the independent variable that leads to transformation of signal. Here, a continuous time signal f of minus t is obtained from the reflection of the signal f of t about 0. This basic transformation of time is called time reversal. The same transformation is possible for discrete time signals. Now moving on for a continuous time signal x of t, which is related by another basic transformation named as time scaling. The x of t signal can be represented as x of t divided by 2 and x of 2t with the help of time scaling. We can represent x of t as a tape recording, then x of t divided by 2 is the same recording played at half its original pace, and x of 2t is yet again the same recording played at twice its pace. The same transformation is possible for discrete time signal. A continuous time signal f of t is related by time shift property. The signal f of small t minus capital T represents a delayed or advanced version of f of t. The same transformation can be shown for discrete time signal. The signals which are represented using time shift are applied in radar, sonar, and seismic signal processing. Related terms are